Hi everyone, this video is part 6 of data visualization. Let's move towards the real agenda of today's session. So today we will learn about box plots, and we will learn about it by reading some theory and doing some practical work. So let's get started. So what is a box plot? A box plot is a chart that is used to display the data in the form of distribution by making box plots for each of them. The distribution of information is based on 5 sets. First one is minimum, the next one is first quartile, the next one is median, next we have third quartile, and then we have maximum. It shows the median, range, and the quartiles. This tells us about data's dispersion. A box plot can also have whiskers. Any data points that extend the ends of the whiskers are considered outliers and shown as dots. So, how to make a box plot? A box plot can be made with two different methods. Let's have a look at the first one. You can make a box plot by using the box plot function in RStudio, or you can use the ggplot2 package. Let's see the syntax for the first one. Just use the box plot keyword, pass the variable, and some parameters. Now let's move to RStudio to see how it actually works. Well, first of all, I will read the built-in dataset of empty cars. And here you can see the values and some columns inside this dataset. Let's say I want to make a box plot of gear versus MPG. So in order to do that, I will use the box plot keyword. All right. And here I will say take gear on x-axis and MPG on y-axis. And the data set is of empty cars. All right. And I say main equals to gear versus MPG box plots. I had to say MPG on the left side and gear on the y-axis. All right, so now let's run it. Okay, that's great. So you can see your gears on the x-axis and MPG on y-axis. Now let's take this box plot, for example, of gear 4. You can see that the area that is below this black line that seems to be bold is the area of first quartile. And the area above it is the third quartile, and this line shows the median. So this actually tells that for the gearbox of 4, the median values are almost 24, and the median values for the box plot of 3 are around 16, and for the gearbox 5, these values are around 19. So that is how you can interpret the information from your box plots. Now let's say I want to make a box plot of displacement and cylinders. All right. So you can see a point here above the 6. Now this point shows the outlier because this point is outside the box plot. And for the gearbox 4, you can see that most of the values relies in the first quartile. Now, an interesting thing can be done here by passing a parameter of, let's say, notch equals to true. You can see here that the shape has been changed of your box plots. Now, this is not suitable here to use because you can see here that some notches went outside the box plots. Well, an important point to consider about notch is that they are used if you want to see that the median of two or more groups match with each other. Well, now let's move back to slides. The second method for constructing a box plot is with the help of ggplot2 package. You have to map a continuous variable to y and a discrete variable to x using geomBoxPlot function. Let's see the syntax. First of all, you will use the ggplot function, and then you will use the geom of geomBoxPlot. Here you will pass the data frame and then the static functions either in the in the ggplot2 package function or geomBoxPlot. Let's do some practical work. For instance, I have a data frame of, let's say, game data. All right. This contains columns such as cards, results, and scores. Now, what I will do here is that, first of all, I will load the library of ggplot2 package. All right. And here I will say GameBox. And inside this variable, I will create the function of ggplot2. I will pass the data frame, which is game data. And in the static function, I will pass cards on the x-axis and scores on the y-axis. All right. And here I will use the geom of geomBox plot. All right. Let's say GameBox. And now it's time to run it. You can see a pretty box plot here. And now you know that these lines are the medians and the area below it is the first quartile and this is the third quartile. These are the cards, which are diamond, heart, and spades on x-axis, and these are the scores on y-axis. All right, let's do something interesting here. Let's say I have a variable with the name of GameBox1, and this time in the static function, I use a parameter of fill equals to, and the variable is result. Let's run it. You can see pretty combination of box plots here. They are according to the value of lost and won. You can see here that the scores for the won in diamond and hearts are much higher as compared to spades. And most of the values that won in the spades are having a score of more than 300 on average. And that is almost same for the hearts. But for the spades, the median value for winning is around 200 on average. Let's move forward. Now you have a built-in dataset with the name of diamonds. All right. Let's load it. And for instance, I have a variable of, let's say, GameBox2. All right. And I pass the data set of diamonds. Here I say take cut on x-axis, this column, and I will say price should be on y-axis. And for the time being, I won't use the fill. Let's use it. All right, so you can see that there are a lot of circles or points above or outside your box plots, and all of them are outliers. So outliers are basically some values that are really extreme values in your dataset, or they are also known as abnormal values. You can see the median values for each of the cut, which is almost same. Let's create another box plot. And this time I will just simply change the variable with clarity instead of cut. and you can see the price for each of the clarity, and there is a gap between these outliers. So you can see that the last value was here and the next increase was here. Anyway, let's try to use the fill function here. Once again, I say cut fill equals to, and fill them according to their color. Oh, so you can see here that you have different cuts here, and the yellow is represented by J, D is represented by purple, and you can see here that in very good cuts and in premium cuts or in the ideal cuts, the color is usually J, as you can see here, and the median values for these colors and these cuts is usually higher than the rest of the color and the cuts. Now, what if a person wants to change their view of this plot? So they will just simply say box plot 5 plus code flip. All right, with the help of flip function, we can just simply change the orientation, as you can see here. Well, now what if I change the notch in my box plots? Let's say box plot 6, and you can clearly see here that I'm going to pass the parameter of notch equals to true in my geom plot function. Well, it does not seem to have that much effect because we have a lot of observations in this dataset, and furthermore, it's not suitable with this variable. Anyway, let's move forward. Now, for instance, I have another dataset with the name of MPG, all right? And here I have some columns such as class, CDY, drive, and so on. Now, what I'm going to do here is that I will take the same chunk of code and I'll say box plot 7. All right. Here I will pass the dataset MPG, and I say take class on x-axis and CDY on y-axis. Now let's see the simple box plot, and let's do some twist here. What I'm going to do is that box plot 8, here in the geom box plot function, I will say outlier dot color equals to, and I say blue, and outlier dot shade equals to 1, and I say outlier dot size equals to 3. Let's run it. You can see here that the points that are outliers are now changed. Their color is blue, their size is more increased, and the shape is in the form of a circle. So that is how you can also change the view of your outliers in the box plot. Now one can also do something like, let me show you. Let's say geom box plot 9, and here after the geom box plot, I use one more function of geom, let's say geom line, and what it's going to do is to make lines inside the box plots as well. Let's see what difference does it make. So here's the output. Now you might be wondering that if we could use the geom box plot with the phasor drive function or not. Let's find out. I'm going to read the diamond dataset. The cut will be on x-axis and the price will be on y-axis. Fill equals to color. And in the phasor graph, I will also use color. All right. Let's run it. So here's a beautiful output. You can see your kit on the x-axis and price on the y-axis, and these values are according to the colors. Even if you remove fully crystal color, it will still be good. It will just remove the color from each of the subplot. Now let's get back to slides. Alright guys, so this is the end of today's video. You have learned how to use the box plot and make it using by utilizing the RS box plot function and also the geom box plot function of ggplot2 package. Now I have designed some homework for you. Here is the link of the dataset. Alright, and here are some tasks. Make a box plot with both methods and write down the insights you have found after making a box plot. Now good luck, see you next time.